Alright, so they say that practice makes perfect, so we will continue to practice proving trig identities, and at any point I encourage you to pause this video and try to see if you can prove it. If you get stuck, then press play and keep watching, but like I said before, the best way to get good at these is to just simply keep doing them until they start to click. Strategy 1, always begin with a more complicated side. Well, if we're looking at number 3, the left-hand side, that's what LHS means, left-hand side, is clearly the more complicated side. Okay, then the next strategy we do, try to make well-known identities appear. Well, there is something squared, and there is an identity for secant squared. I'm not sure that would make it easier, though, because we're trying to convert it to something pretty simple. Normal algebra techniques factoring, well, there's nothing I could factor out of this, so that leaves strategy 4. When in doubt, change everything to sines and cosines. Okay, and we can see up here, tangent, it's not written, but tangent is the same as sine over cosine. So that's how you would change tangent. Secant is the same as 1 over cosine, and cotan is just the reverse of tan. So let's try that and see if we can make something happen out of that. So tangent is the same as sine over cosine. I'm leaving out the x's just to save space, but those should be there. Minus secant is the same as 1 over cosine squared, and cotangent is the same as cosine over sine. And again, we're only touching the left-hand side. We're leaving the right side alone because that's the side we're trying to make it identical to. Alright, so notice here that we have a cosine on the top that can cancel and become 1, and one of these cosines on the bottom can cancel. So now we're left with sine over cosine minus 1 times 1 is 1, and cosine times sine is cosine sine, or cosine times sine. Okay, now we have some fractions. How do we add fractions together? We need to make sure that we have a common denominator. And in this case, the common denominator would be cosine times sine, which is here. So this one needs to get multiplied by sine. So times sine times sine. That's going to equal sine times sine is sine squared. And then we still have over sine times cosine minus 1 over, and I'm just going to reverse the order there. It used to be cosine sine, now it's sine times cosine. Since we have a common denominator, now we can combine these together. So we have sine squared minus 1 over sine cosine. Let's go back to our strategies. One of the strategies says try to make well-known identities or some variation appear. So we have something that looks almost like this. 1 minus sine squared, that equals cosine squared. The only problem is we don't have a 1 minus sine squared. We have a sine squared minus 1. So what we can do to get around that is to factor out a negative 1. If you pull a negative 1 out from there, you get negative sine squared. I'm just reversing the order. If you pull a negative 1 out from negative 1, you get positive 1. Okay, I reverse those just so we can see where that's coming from. Okay, what is 1 minus sine squared? That's the same thing as cosine squared. So now we have negative 1 times cosine squared, that's negative cosine squared, over sine times cosine. And now if you look back at what we're trying to prove that this equals negative cotangent. So here's what we can do. We can cancel this cosine here and one of these two, so we're left with negative cos over sine, and that is equal to negative cotangent. Cotangent is cosine over sine. So we proved that the left-hand side is identical to the right. That's all we had to do. Okay, this one right here, this number 4, it says, same thing, we have to begin with a more complicated side. They both look fairly complicated, but maybe the right side is slightly more so. And then strategy number 2 says try to make well-known identities appear. Well, this one right here is appearing right there. That's the most well-known of all identities. So let's start with the right-hand side, and we will try to change it. And I can already tell that we may have to end up getting these to meet in the middle somehow. We'll see if that ends up happening. But this sine squared plus cosine squared, that equals 1. So we have 1 over sec squared. And 1 over sec is another identity. 1 over sec is this right here. 1 over sec is another name for cosine. So 1 over sec squared, that's the same thing as cosine squared of x. So now we're going to have to make these meet in the middle because we haven't shown that it's the same. Although notice if you look at the left-hand side, the left-hand side does have a cosine squared in it. So here's a question for you to think about. What do these have to end up doing to each other so that all we're left with is cosine squared? Well, let's try that out. So cosine squared, when in doubt, change everything into sines and cosines. So if you look at it, I'll make a blue line so you can see that it's this line right here. When in doubt, change everything to sines and cosines. That's another strategy. So that's sine. How do I change cosecant into something with sines? Cosecant, if you look at that identity list up top, just scroll up a little bit, cosecant is 1 over sine. So that means cosecant squared would be 1 over sine squared. And then what happens, sine squared times 1 over sine squared? Those cancel. We're left with cosine squared over 1, which is just the same as cosine squared. So that's another example of two identities meeting in the middle. And we have proven our identity.